Hello everyone, once again. Today's we have some special lecture that is megger. Uh, for this, I have talking about in previous lectures also. That is a mega ohm resistance meter. It is used for measuring the high resistance, especially. For a definition purposes, it is a megger instrument which is used for resistance of insulation. Basically, is principle is basically on the comparison, as the resistance of insulation are being compared with some unknown resistances. If the insulation is high, the pointer moving deflect toward the infinity or higher resistance part. If resistance is very low, it indicate the zero resistance. So megger is accuracy of this megger is compared to other instruments is very high, as I suggested in before previous lectures also. What is the basic principle behind this construction of megger? As you see in this particular construction, having some it is a mechanical moving type of a crank handle type your megger. Some other today we have also electronic or digital type meggers also available. It consisting of some DC generator. If we hold a clutch or crank handle and we put like moving it to toward the around 100 or 200 with speed or 200 rpm, this DC generator provides some thousand of volt across this testing terminal X and Y. Okay, this testing terminal providing thousand of volt across this terminal X and Y. If the resistance is high, if resistance across this testing terminal is high, its voltage and its current is measured by two coils. First, coil A and coil B. Okay, let's start with some of the working terminologies. So, starting, if we have some resistance, the point this and point this. Note this particular point. Okay, the connectivity is like this. From this particular guideline, see the connectivity from the resistance. The connection is like this from this particular point to this current coil to current coil B to this particular again to those DC generator. So it acts as a, so this particular B coil carrying the series connection. So it measure the current in system first, where coil A is in parallel with this terminal resistance carrying measuring the voltage B. So due to this coil A and coil B, there should be some fluctuation, or we measure the resistance which can be measured on toward this pointer. Okay, if resistance is very high, so there should be smaller current, there should be some smaller current. Then this particular coil B having the high magnetism, so this coil B attract the pointer toward the particular each particular point, and this point toward the infinity. If this particular coil having the small resistance, then voltage drop across is will small, and the magnetic field across the coil A is small, where the magnetic field in coil B is greater. So coil B attract the particular pointer across the zero position. So by this particular function of attraction of coil A and coil B, as they measure the voltage of measure voltage and current, they decided the resistance in the circuit. Okay, there's a basic working behind the this working function of our mega ohm resistance meter. Okay, in the construction, basically it is an electromagnetic attraction principle, where there is a centrifugal clutch on the generator in the mechanism, where the insulation with the low resistance tested using the steady state voltage. When the armature of generator is rotated by this hand driven crank clutch lever, it is designed to slip as a predetermined speed, like as I say 100 rpm approximately. With some constant speed, there is a constant voltage around 1000 of volts should be generated. This coil A and B point are coil and B are been there to measure the moving coil voltmeter and ammeter. Both are combined to form a instrument. The hot terminal of equipment whose insulation resistance to be measured connected, as I say, between X and B. If the voltage generated at the terminal point across a coil A through a resistance R1, Okay, when an XMI has free initially, no current basically flow through current P, the torque produced by A rotate moving to the show infinity. As I say, if there is no resistance or infinite resistance should be there, as X and Y will be open circuited, there is no current flow through coil B, and only coil A will be activated in this manner, and that coil A attract the particular pointer toward this and show the infinity. If we short circuiting or provided some resistance, then there should be some current passing through B and pointer move toward the zero position. And this interaction of coil A and coil B indicate the value of resistance, where the, as I say, you will indicated that 5 maximum 500 volt will be generated by this 1000 volt to 2500 volt, 5000 volt either should be generated by this particular generators. Okay, now basic construction is same, where as I say there are two type of megas are been there. First, as I say, hand driven. This should be used in our currently, before 2015 we used this crank lever type megas in overall apparatus of measurement or industry as well as, but now today we use this type of electronic measurement devices where we are having some battery operated versions where we put some only batteries and they show the resistance. We do not be crank lever the thousand of volt across it. It manages own voltage across it using some your DC to DC converter devices. Okay, now, talking about some of the important point regarding this maker, as I say, the minimum value of 1 mega of insulation should be at least 1 mega for 1000 volts. Now, what is this particular values give reading regarding insulation? If the value of insulation is between 5 ohm to 10 ohm, it will be measured by the your mega. It will say it is abnormal rating. So insulation is not good. If your value between 10 to 50 mega ohm, we say it is a good insulation. There should be no connectivity between the two phases. If resistance between 5 to 100 mega ohm, say it is a very good insulation, and it is 100 mega ohm or infinity, say it is a very excellent measurement devices. So talking about its uses, the use for measurement of insulation of wire. So in case if we put in your home appliances or internal wiring of your houses, if the insulation is not proper, it will leak your current. And as if we use a proper type of conductive iron pipes, it will causing shock to body. In my house, it is one of the example. It is an older home of around 20-year old, and some conductive PVC pipes are been there in the home. As I say, the wires are been very weak and insulation had been damaged by year and year. Some of the leakage current been flowing from PVC. Okay, this PVC pipe are being enclosed in the your walls. As the rainy season is there, humidity are been there on your wall. If you touch your particular wall, I will touch my wall, as the PVC carries some leakage current, and this leakage current is flowing through this particular humidity or moisture through my hand. There is some sparking or some current should be flowing through wall. It is one of the bad example for your electrical wiring system. So we use some proper insulation for this particular shock prevention also. So testing of battery and relays grounds are also been there. Installing windings are been there. And a major advantage is a very simple machine. We use some small DC generator or permanent magnet type generators. It does not require some external resources or batteries plug to use. Cost is very low. As I say, physical damage can be identified by this particular magger. As I say, it does not take so much time as a loss of charge method, but some of the disadvantages, time required for measurement is very high, but it is a lower than basically loss of charge method. Accuracy is very not high with respect to loss of charge method. This is one of the disadvantages. That's all. Thank you so much for this particular lecture. We will talking about mega ohm resistance measurement device. Thank you so much.